Hello,
Welcome.
good morning. We start in 2 minutes.
I assume you can see my screen share?
Yes.
Wonderful.
Perfect. 12:02. Hello. Good morning, everyone. Thank you for joining us on this wonderful day. Today, we have Rich McGraw, our Vice President at Improving with Us, talking about modern data platforms and pipelines a long way from ETL. Rich received a Bachelor of Science in Computer Science from the University of South Carolina Honors College in 2002 and AME in Computer Science in 2004. He also received an MBA from the University of Georgia Executive MBA program in 2020. With over 16 years in IT consulting, he has extensive experience creating enterprise application platforms, focusing on scalable database and integration technologies and patterns, reporting, data analytics, enterprise application architecture, API design, API management, and data and API security. He has been involved in a lead numerous software development and data services projects for clients including AT&T, Disney, and Microsoft. As CTO, he has also overseen and advised on the development of a criminal history background check application through the Center for Naval Analysis and the Centers for Medicare and Medicaid Services, which is in use by agencies across 20 states, including the management and implementation of data privacy and security compliance programs. He is Rich, and welcome everyone.
Good afternoon or good morning, depending on where you are. Thank you for that intro, and we will hop right into it. As we go through this today, feel free to put questions into the Q&A box at any time, either we'll answer them as we go. Feel free to interrupt, or we'll review them at the end if they are more appropriate. So put those in as we go, and please feel free to ask questions. So I'm Rich McGraw. I'm not going to really say much more about myself, but I've been here at Improving for 17 years, and data services is one of the passions and practices that I've been with and very proud of here for quite a long time. So today, what we want to talk about is how the modern data story has begun to change and impact both the platforms that we're using and how we develop data pipelines on those platforms. So to do that, we're going to talk very, very quickly about a kind of brief history of how we got here. Then we're going to talk about kind of what's been missing in our data platforms and our data ecosystem that the modern data story can help us address or can help enhance the solutions we've been delivering for decades. Then we're going to dive in a bit into what is different about modern data platforms what type of capabilities and services they provide, how we should approach looking at modern data pipelines, and some of the different practices we should apply to those as we begin to unlock this value. And then we'll wrap up with some closing thoughts. It's a lot of content, so it's going to go fast, and there's going to be a lot of things. If I'm hand waving over something that you want more details on, again, please feel free to drop something into the Q&A, and we'll do our best to get it answered. So first, our brief story of data, our brief story of kind of how we got here over the years or over the decades, right? Really started pretty simply. We needed to store data and retrieve it, right? And you know, there was a point where you know, we could do that. We built databases and the world was good. But as soon as we get one capability, right, you begin to see how this can be leveraged and implemented in other places. So how can we use it with other sources of data, right? We now have too many systems that have similar bits of data in them. Can we look at the data in multiple ways? How do we make something better than just static reports? And so we added data warehouses. We started talking about multi-dimensional models, being OLAP or tabular. Right? Then we start talking about, well, big data, right? We're getting massive amounts of data. Can we store these large amounts? Can we process larger amounts of data than we ever really thought of fitting in warehouses? Right? And that's where we began to add in data lakes. We came up with the wonderful buzz of big data. But then we need to move it in the cloud. We need to support multiple platforms. We need analytics. We need data science, right? AI/ML. It's getting really complicated, right? How do we have a solution that covers all of that and more, right? In an ever-evolving field. Well, the way I like to look at this is it's not really one problem or one solution, right? It's not one problem that we're going to find a product to fix. Data is really a kind of continuum, right, of features, of capabilities, and solutions we need to bring to bear. Everywhere from data acquisition through persistence, how we visualize it, how we do analytics. And when we talk about a modern data platform, we really need to talk about how something addresses this whole view of what we need to do with our data products, and not just the view of, well, what could we do with SQL? What could we do with a data warehouse or with big data, right? What can we put in Hadoop? That there's no one answer to this solution, but to have a truly mature data ecosystem, we need to be able to address this holistic view of how we gather information, how we store and query it, and how we turn that into effective decisions for the business. And that really is the piece that I think is where we should value our maturity, right? It's not that we have newer products, right? Or I'm using a newer technology than you. I have a more mature data organization. It's really how core is the data to what I'm doing as a business, right? I either can simply know I have data and begin to leverage it. I can see myself as a data-driven business and that it is critical to my success, right? Or in the most mature, data is key to driving business decisions, to driving the day-to-day business and optimizing it, right? And that's really where we've unlocked the most value of data, which is where we want to get with these modern platforms. The problem is, as we do that, as we mature, we actually have competing problems, not just a large ecosystem of different things we need to solve, but they pull us in different directions, right? As I add more variety of data and larger volumes of data, and I receive that data and need to report on that data more quickly, these are all different needs, and different platforms solve each of those problems in more optimal ways. So the question really becomes, as we look at a modern data system, how do we build something that can scale and address the breadth of things we need to do with data, but also the scale, also the increasing needs across these different competing pressures that we put on our data systems. So as we do that, we want to talk about what modern data means, because it is a buzzword. And so whatever it means today probably is a little different than what it meant a few years ago, and probably still going to be different than what it means in a few years. But I do think we can distill it down to what does it do differently? What does it add to our data solutions? And anytime we think about how something adds or disrupts an existing space, I like to think of it in two different ways. What new capabilities does it bring? And then what efficiencies and speeds and costs and availability reductions can it add, right? What does it add that's new, and what does it take and simply make better? And so first, I want to talk real briefly here about some of the new capabilities, because as we get into the platforms and as we get to the pipelines, they're going to make a lot more sense if we understand why they're different, and why some of this unlocks value that we didn't get out of our older platforms. So first, we want to talk about the idea of structured and unstructured data. So structured data is really what we've worked with for decades, right? It's the data we know that we can define, we can build structures that we're going to put it in nicely defined tables. When we put it in there, we can say we know it, it's cleaned, we've managed it, it's easy to query, I know what's going to be in there. This has been the traditional world of data for most of its existence in our systems. But it's not the only kind of data we have. Ever more increasingly, we have to deal with unstructured data, right? And that is raw data that we've yet to categorize, that we've yet to perfectly put in boxes, right? It may be coming in various formats. It's likely coming in very quickly. It's certainly something we can search, right? And we do have a lot of tools for search across vast amounts of unstructured data. But it's not something that we can necessarily mine and query and leverage in the same way as we do structured data. And really, when the big data story started, right, these were the two sides of the worlds that we were trying to bridge. We had solutions that could deal with structured data. We had massive new channels of unstructured data coming in, and we needed to be able to leverage them. And things like MapReduce and Hadoop do a great job of letting us do that. But as we talk about the true modern data platform, what's really going to become important is this idea of semi-structured data. This is data that's loosely organized, that we've done some of the things we would do traditionally for structured data with. We've stored it in formats where we've identified pieces of it that we can categorize and define with the same type of rigor that we do in structured data. But we haven't thrown away everything that doesn't fit into the structured data model. Instead, we know there's other data that either is not valuable to fully categorize, that's too variant to categorize, or that we believe will have value, but we're not ready to invest in it yet. And semi-structured will let us not lose that data, keep its context, get the value we can out of it, while still leveraging some of the simplicity and ease of use we get out of the structured data tools. So if this idea isn't completely new, right, if we've been dealing with structured data for decades, there must have always been unstructured data we were fitting into that. Why has this changed? Why is this interest now as we talk about modern data? Well, there's a few reasons. One is we simply developed better tools that can handle it, right? We also simply can store it cheaply today, right? There was a time when storage was very expensive, and the idea that we would store unused data simply was really a non-starter, right? But with the cloud, we've gotten to a point where that storage may not be free, but it is infinitesimally cheaper, right? And is no longer the driving constraint. But more importantly than either of those, we simply have a whole lot more of it, right? The way the IT world has evolved, data collection systems have evolved, the way the internet has enabled systems to communicate together, We simply are getting more unstructured data today than we ever did, right? It is not only out past the amount of structured data that we receive, it is vastly out past it and continues to grow at a much faster rate. So as the world of data continues to explode, we simply must be able to leverage the value that we can get out of what's becoming the most common and most prevalent form of data we're going to find. Additionally, as the type of data we're getting changes, the kind of users who need access to that data is changing as well, right? We are well past the days of IT building a suite of 150 reports that they publish out to an enterprise, and that's exactly how everyone can get all of their data, right? We need data analytics. We need to be able to look at the data to ask questions and discover new things that we didn't expect, right? Or we didn't predefine. And that is no longer, right, the purview of just data scientists, right? As we entered the 2010s, it was that data scientists were really going to kind of rule this area of the data landscape. There's simply not enough of them. And we have too much expertise embedded in our businesses that we're not leveraging. If only data scientists can get out and use this data for the ability to answer and investigate questions. And so that's where we have a real need to empower non-engineers, empower power users, business users to be the analysts, right? And to access this data. And the growth of those positions in companies has well outpaced that of data scientists. And there is simply a need for our systems to serve, right, this population of users. In addition to these new capabilities, we have things that we simply want to do better, right? What have we done before that we can really unlock new ways or much better and more efficient ways of addressing? And as we dive into that a little later in the presentation, one of the things we're going to talk about a lot is how we develop data. So not really what the end solution looks like, but what does it take us to get there? And the comparison I want to make here early to keep in your heads is that there's been a lot of progress over the last decade in software development and the maturity of how we work together between development and QA and operations to develop software in repeatable, agile manners where we can rapidly release functionality that doesn't break old functionality and allows us to address business needs in a much shorter time frame that's more reactive to the business and changing scenarios. But data development hasn't really made that change. Data development still has developers who pass things off to QA to test. Maybe that comes back and then they give something to deploy to operations, and it's all in different environments that don't really match or talk to each other. And we're really lucky if all three parties actually are in sync and talking to each other. It's really usually more, well, QA said it was good, development writes some scripts and maybe gives it to operations if operations doesn't just have the data developers deploy it directly, right? This is how we did software 40 years ago, but it's how we've been doing data even in the very recent past. So what can we do and what can platforms do to unlock everything we get out of software development today? How we look at designs, requirements, implementation, but most importantly, the evolution of our solutions once we've put them into production. How do we handle data solutions when requirements and schemas and platforms or the needs for use change? Because in a traditional data warehouse, right, refactoring or changing fundamental pieces is incredibly expensive and is an incredibly long cycle. How can we take that and use these platforms to treat this in a much more agile way like we do software development? And a large part of that as well, right, is going to be how we're able to deploy, test, and integrate that cycle. We also need to look at how we test data. Because if we think back, right, and we think of unit testing, integration testing, and end-to-end testing, I would kind of challenge anyone to look at their data practice and say, if this pyramid, right, reflects how much effort, time that you place in each of these kinds of testings, which ones represent what you do in software, and which ones represent what you do in data. And I would certainly posit that the one on the left is much, much more common in the data world. Right? The idea of unit testing, data pipelines, right, certainly isn't widespread. Basic integration testing certainly exists, but most thorough data testing is happening end-to-end testing in organizations. And that may be where today it feels like it's easier to define and easier to run it, because there are a lot of technical challenges to doing integration and unit testing that are different in data than software development. But the problem that isn't different is that things are a lot more expensive to fix when we find them in the later testing cycles. And so if we think about how we want our platforms to be able to adjust to the business, we want them to be sustainable. We want to be able to change them as they grow. We really have to make sure that what we're doing is putting our testing efforts where it can find issues at the stages that it's cheaper and faster for us to recover from. And so there's an absolute need in these platforms for us to kind of drastically shift how we test data projects so that we can be more agile and move much more quickly, not only among releases and among fixes, but as things evolve and change over time, right? So we need both. We need new capabilities and we need efficiencies out of these new platforms. So with that, let's talk about the platforms. So if we want to talk about what is a modern data platform, right? We're talking about a moving target. So here I have a wonderful landscape map that a capital group, First Mark, puts out each year of the data landscape in 2016, which due to the buzz at the time, they called the big data landscape. And that's pretty crowded, but I can recognize some logos on it. I can read it. It looks okay on the screen here. But let's get a little more modern. We'll go with 2020, data and AI. That's a little harder to read, but it's there, right? It's getting a little overwhelming. And then today, I'm not even sure that this is readable with a microscope, right? The amount of solutions and choices and categories of solutions is simply mind-blowing, right? And is going to continue to grow, right? I don't expect that this diagram is going to be smaller in 2024 or 2025. So with that, right, we could either spend the next 3 months going through and detailing each little name on that list and trying to compare them all to decide what we want to do. Or we've got to figure out some other way to move forward and leverage this ecosystem. And so what we try and tell people to do, or what I believe in pretty heavily here, is rather than focusing on the platforms, we need to start with capabilities. We need to pick what capabilities out of a modern data platform we want. And then based on those capabilities, we're going to pick building blocks. We're going to try and build a strong, flexible foundation that uses pieces of that ecosystem to help us build those capabilities and start this as a roadmap that we'll continue to build on. But most importantly, we expect that we're going to be wrong when we do it. Because with that many platforms and that much change and churn in the market, There's no way to pick right. There's no way to pick the perfect platform that is definitely going to be the platform that stays on top in 5 years and isn't replaced by something even from the same vendor. So what we have to do is focus on the capabilities we need, because that's the core that'll be a through line, and build things in such a way that if we make a wrong choice on a platform, we haven't locked ourselves into a corner. We've given ourselves the flexibility and the ability with the other tools we use in the ecosystem to replace just that piece, right, without ripping everything to the ground and continue to grow, right? And this is very much what people do in software development, right? But in the data world where, we'll still find mainframes with DB2, right, or SQL Server 2015 or 2010 sitting out there because it's been the core data store for a system for a decade. We have to be able to detach ourselves from the platform of choice and look at the capability of choice. As we do that, let's talk about a few of those core capabilities. One of them, and really core to the pipeline story we're going to get to in a little bit, is the ETL versus ELT change. And this seems very minor, right? Or perhaps even like a typo on a slide. But it really is a fundamental change in the way we've begun to treat data in the modern ecosystem versus what we did a decade or more ago. It used to be we'd get raw data, right? We'd prepare it into those perfect structures, right? That we knew matched what we wanted, and that's what we stored. And then we came back to those data warehouses or those data marts, and that's how we got our data. The difference between ETL and ELT is that I don't make the assumption that I know how I want to use the data. Instead, can I store the data in a way, right, that I can use it in multiple ways down the line? And as my needs change, as I don't need shredded carrots, but I want chopped, right, I can make that change based on the data I've stored. And so this is kind of the core fundamental difference as we start talking about pipeline tools and approaches and patterns in the modern data world. And it really makes a lot more sense if you think back to the structured versus semi-structured and unstructured data, right? If I'm storing just structured data, right, it is a very ETL problem. I know exactly how I want to chop my carrots up. I turn my data into those structures, I store it, right? And anyone who wants the data is going to come and get it in this way. When I begin to look at unstructured data, right, if I just store all unstructured data, it may take me too long, right, to be able to figure out a way to use it, right? Not really sure what carrots grow from, right? Seeds or sprouts or cuttings, but that's not what we put in the refrigerator, right? We do have grown, ready, and cleaned carrots. We want the semi-structured data that we can already get some value out of. We know some things about it that we know how we want to address it. And then there's other pieces we want flexibility with moving forward. And that's what that ETL versus ELT approach is going to give us. We also want more flexibility in how we actually run, store, or build our systems from a pure infrastructure standpoint. Right? It used to be with a traditional database system, right? SQL or Oracle. I had a server, and that server stored the data and did the work. And well, maybe I had two because I needed high availability or I needed more capacity. And when I reached the limit of those, I made them bigger, right? I bought a bigger box. But in the modern world, what we want to look at is kind of fundamentally, how do we make this a more flexible architecture and approach? How do we treat how we store our data different from what processes the data? Can we have storage, and can we bring compute assets to bear on that storage? And then when we need more, right, when we've outgrown it, all we have to do is bring more resources to the table. We're no longer limited by scaling one thing, right? And this is really the beauty of the cloud, because moving from 4 to 8, 64 workers, right, can be as simple as a slider sometimes, right? Or in a containerized approach, it's just spin up more. And it allows you to scale in a very much more dynamic way. We also have entire new types of data, like streaming data or real-time data that we need to deal with as a capability in these platforms, where we're doing continuous IoT, import, durable storage. We're processing things in not just near real time, but in real time. We need aggregations, analytics, monitoring, reporting, where this isn't something where we can do a data load every 5 minutes or every 10 minutes, but we really need to be able to process things as they come in. To solve all these capabilities, right, we're never going to find a single tool. And if we do, right, we're probably investing too much, right, in that one piece that we're going to get locked into. So this is where we really want to look at the modern data platform as not a single SKU, right, or a single product, but as an ecosystem. How are we bringing capabilities around data and big data and streaming data, plus tools and compute, all together to build us our ecosystem? And there's some pretty common ways platforms look at this today. So one is the data lake, or lakehouse, or delta lake, or many other variants of it you may hear. And they all are different. I'm hand waving a bit, but at their core, right, they are a layer of storage that's attached to the ability to put some analytical processing or some compute onto it, right? And it's a store that can store both unstructured, semi-structured, and structured data all together, right? So that I can really store that data as I'm ready to use it. I can structure that I already know, and I don't have to lose what I don't. And this is not platform specific, right? This is an Azure image I'm showing you here, but the AWS image, right, tells you the same story, right? A data lake either place is that storage tier that we can attach compute and attach all these services around. And even as you look at these offerings, right, there's a lot of other companies and solutions that are part of them, be it Spark or Hadoop or USQL, right? These aren't platforms that Microsoft or AWS wrote. These are other solutions they're bringing to bear along, right, with their products. We also have products that are a little more wrapped together, such as Snowflake, right? A data architecture built for the cloud, right? But at its core, it has a centralized storage layer, right? It has a compute layer that's separate on top of that and services that wrap around it, right? It's a great platform and it has some amazing power to it. But even it requires an ecosystem, right? If you look at their product page, by the time you're looking at the story of how to do all these things, right, you're bringing in a lot of partner solutions because, again, no one thing solves it all, right? We talk about Amazon, Redshift, right? Could be a good example of a competitor to Snowflake here. But as soon as we begin to build out, right, our solutions in AWS, we might need Redshift and QuickSight and OpenSearch and EMR and, right? There's really an ecosystem of solutions there. And if we try and map them across, right, they have similar solutions that match capabilities on each of the other platforms. Microsoft's recently wrapped a lot of their services together into one story with Microsoft Fabric, right? But it's really still the 7 core workloads, right, wrapped together into a platform where those workloads can still be switched out for others. It's, you know, its core message that it's lake-centric and an open platform, that you're not locked into any one of their workloads. So again, when we talk about products, what I really want to switch the conversation to is to talk about an ecosystem. What's the set of products we're going to use? What are the core ones we're going to start with that we can then build the rest of our solutions on top of. And then once we have the platforms, we have to build some things on it, right? So that's where we start talking about modern data pipelines. And just like when we talked about platforms or general modern data, we want to talk about what's different. What is different about a modern data platform than what someone built in SSIS or Informatica or any of the other tools, right, 10 or 15 years ago? Because unless something's fundamentally different, we're probably missing the boat in how to leverage these new platforms. So remember back, right? I'm not going to go through it in detail again, but we want more of an ELT approach than an ETL. And we want to think about how we can store data somewhere that we can bring compute to it. So how do we have pipelines that leverage kind of those two core fundamental ways we want to approach a modern system? Well, one of them is, regardless of how we build it, we think about frameworks that do data processing. And there may be multiple ways I write pipelines that run across these processes. And these processes have two main ways that we're going to look at how they execute. One is data parallel or parallel frameworks. These are really good for batch processing, right? So I either have a large set of data or continued sets of data changes that I want to process. I want to be able to spin up more and more workers, right? Or compute nodes as I get more and more volume of data, as I need more capacity. And each worker is just going to do part of the work. They don't need to see the whole picture. They can process part of the set that's coming in. So think about one big question that I want to split amongst a lot of workers to solve, right? Look through the last 2 years of website data and tell me what are the pages that are, most valuable, right, in changing or attracting different customer behavior, right? I'm going to look over a massive set of data. I don't need each individual worker to look at it all. I can split it up and ask that one question of many workers and break the problem down into smaller chunks. The other side of the coin, I may have something that is task parallel, right? And this is where we begin to think more about real-time streaming, IoT, right? Low latency data. And this is where I need more workers because I need to answer lots and lots of small questions, or I need to react to lots of small changes that are occurring rapidly at the same time. And that's where we talk about platforms like Kafka or Storm or Samza. These platforms are common along a lot of tools, and there's a lot of other ones. But in general, we want to make sure we're bringing the right ones to bear in our pipeline, depending on if our pipeline's asking that big question with many workers or that small question, right, that we're going to have lots and lots and lots of volume of. So one example, so that we can dive a little more deeply in a pipeline here, is I'm going to look at DBT. This is a platform that lets me write data pipelines that run on core data platforms. So this is not a data platform itself. This is going to sit on top of Snowflake or Redshift, right, or Google, or a number of other solutions. It lets the developer use SQL or Python or JavaScript, right, to build pipelines that execute on the platforms itself, not in DBT, but also is going to let us handle some parallelism and some other things in it. Now, I'm going to dive into DBT a little bit here because I have to dive into something, right? I want to give you an example. But there are lots of other solutions that do lots of the same things. So if I didn't pick your platform of choice, right, don't be hurt. It's not that the other platforms can't solve many or most of the same problems, right? These are all just different ways to approach, again, these same capabilities. So if I think of DBT, I really want to think about a lot of the efficiencies of what it's bringing, right? We have to assume that the capabilities we're talking about, ELT versus ETL, right, are built in, right? Building compute to the data are built into these platforms. That's core to the processing frameworks. So as I talk about pipeline tools, I want to talk about how they make those things more efficient to use, to build, and to maintain. Right? And that's where we get back to that DevOps and the SDLC story. Let's take some of the maturity we have with software and apply it to data, right? Be it with requirements, design, implementation, testing, or as we said, most importantly, with the evolution of the platform once we've put it out there. So if we talk about something like dbt, right, from a design standpoint, right, it's going to let us design our data solutions by contract, right, with structure and content. And then it's going to help enforce those for us automatically, right? So gone is the day of, well, someone designed a model and hands it to a developer and hopes they implement it, and it's going to drift and we'll never know, right? Or we won't know until something breaks because we made a bad assumption, right? We can take those design elements as the core start of our development and enforce them throughout, just like we would with user stories and contracts and other things and APIs in software development. Documentation and development go hand in hand. It's no longer an activity I come back to afterwards. In fact, the way you develop in dbt, you're decorating documentation throughout. And for things like contracts, the documentation itself may be the start. How do I define the difference between the different parts of my pipelines, being it sources and staging and marts, and apply holistic changes in how I manage and govern those, right? How do I change what I'm persisting as I'm beginning to manage additional volume? How can I tweak my process and decide, well, this can't be a view anymore. It's getting queried too often. I need this to be a persisted table. This becomes not something that is write a new pipeline, but it's just configuration, right? These are the things that kind of naturally I can set and don't worry about as part of the actual lift of building. A lot of that comes from the way they do implementation, right? Using the same set of tools to target any of the systems, right? If I want to move from Snowflake to Redshift, I can, right? Is it 100% perfect? Of course not, because nothing is, right? But the bulk of the code actually can just be repointed. It's modular, it's data first. There's clear structure and dependency management, right? This is starting to feel a lot like object-oriented programming. We can implement processing changes without rewriting the whole pipeline. Materializations, I can change something to load incrementally or take snapshots without writing entirely new ways to process and move the data. As I'm developing it, I can run parts of pipelines, right? It becomes something where I can really begin to break this up between my team and not see my data warehouse and my packages that load it as just monolithic solutions that can change slowly and very rarely. Testing, right? That was the next big one on the list. But what are we testing, right? If we think back again, are we testing more where it's cheaper to fix or more where it's most expensive to fix? Well, with something like dbt, and again, with many of these other platforms, we can have contracts, right, that are tested and verified throughout the process, right? So these are our pieces of design or our stories being enforced automatically. But also, we can have things like unit testing for data, where we can test individual pieces of transformations or models with mock data, scenario definitions, and non-destructive execution, which means you can run this against a real environment without, right, injecting fake data, right, or touching your real data, and truly unit test the individual pieces of your pipeline and code. If I've written my stories, I can validate, right, that they're doing what they're supposed to do. There's packages for DBT out of the box that I can use for this. For integration testing, similarly, I can do this. It does require in DBT a little customization, right? Other tools might require a little more or less, but I can do this now in the data world. End-to-end testing, that's probably what we're already doing, and it's possible. DBT may not be the tool where I want my end-to-end testing to run, but that's fine. I've added unit testing here. That's a new capability. The rest of it, right? That's why we go back to the ecosystem. It's not one tool to solve all the problems. It's tools to bring in those new capabilities and fill those holes in and give us the maturity. We get dependency tracking for schema changes, patterns for backfills and reprocessing forward or backwards from changes. And it's not just runtime, right? These tools integrate just like software development with CI/CD processes, right? They can work with Git and Azure DevOps just like your software products do. They can do builds at runtime from targeted branches so that your latest approved and tested code is what's executed at all times, right? They can handle multi-environment support, something that's been the bane of data testing and development forever, right? And you know, how do I test in QA when it's so different from production, right? There's tools to help streamline this. And all that's great because it's a lot of capability. Somebody probably needs process to drive it, right? There's organizational change that it takes to leverage this as well. And that's where we have lifecycle frameworks, right? And things that have developed over the last few years that really help us build what the business needs in ways that leverage these more modern approaches. And we're almost out of time, which is why this is not something we're diving into now. But Don Sawyer dove into in last week's talk. That's still available, so go out to the Improving Talk site, just where you registered for this talk, and he's got an entire talk just like it, focused on what are those organizational and process changes, right, that we need to make to leverage all the things we can get out of these modern platforms and pipelines. Similarly, right, we're a consulting company. We have an offering called Data Enablement, right, where we embed with your team to help them look through what is that process? How are you doing rapid discovery and data product definition? How are we matching that up with tools? And how are you getting into that rapid development, integration, right, and iteration cycle with development of data, just like you can with development of software? So final thoughts here, right? I think we want to always think when we're looking at modern data, right, of the different problems we're trying to solve. Because there's going to be platforms or products that are really good at solving any one of these problems. But we have to strike a balance because we are going to get pulled in different directions over time. And that's not just because there's different things we have to balance, but because it's really a wide array of problems, from how we acquire data, store it, query it, visualize it, analyze it, how we govern it. And we really have to put that all together into the data ecosystem. And so when we talk about modern data, right, that's really the core lesson that we talk about, is it is an ecosystem. And anybody who tells you it's one product or my one solution can do it all, they may do a ton and really, really well. But we always need to be looking at the ecosystem. How are we going to continue to expand our tools? How are we going to keep up with adding new capabilities? And how can we make data something that isn't something that gets changed and rewritten every 10 or 15 years, but just like the rest of a modern IT organization, can be under continued evolution and improvement, and rapid improvement at that. So real quick, before we hop to Q&A here, This is the second talk in a series of 4 that we've put together this July. I already mentioned Don Zollier's talk on data products from last week. Obviously, this week was data platforms and pipelines. We've got coming up Seeing and Believing with Jason Russell next week. That's going to be about data visualization, reporting, and ad hoc analytics platforms. And then we're going to wrap up with the wonderfully buzzworthy implementation of large language models with modern data products, right? So think ChatGPT and how we can use all this great new capability that seems exciting, but how can we use it in a responsible way? How can we tie it in with the data we have as an organization, right? And really leverage that. So we've got a little bit time left for any questions that didn't get raised to the front as we went through, or that did and I missed. Feel free to reach out to me on LinkedIn or by email, or anyone else at Improving if you just don't like me. We're happy to address this stuff. And let's see if we've got a few questions we can answer at the end.
Perfect. Thank you, Rich. We have a question. Can he describe how he structures this for a client looking for a data strategy? Where does he start? What does the first SOW look like? Where is the typical hook that gets a customer to move?
So I often look at it very much as, I mentioned early on, we want to pick capabilities we can build on. So there's got to be some discussion, right, or planning with them early on, be it an ADS, be it whatever, a phase 0, to help them figure out where they want to go. Because there's not just one answer, right? I can't just walk in and go, here's your modern data stack. Everyone's going to implement it. Because there are so many solutions, and most of them are better than the others at something. So we want to talk to them about that roadmap. But then what's key is the answer is not let's build the whole ecosystem overnight. Because I'm just not a believer in build it and they will come, right? It's hard to show value. So instead, can we take a few of those capabilities and work with the business to tie them to things they need, problems they need to solve, right? Or things they simply can't get out of the solutions they have today. And we can implement those capabilities and a few of those quick win scenarios at the same time. And that way, as we're rolling out capabilities, we're rolling out some business value, right? And then we can continue to iterate and deepen those capabilities, right? And expand out the ecosystem around them. So it is very much a value-driven approach of, if we know we want modern data, do we have a vision already for what that should look like? If not, we can help you with the vision. Then can we figure out what the capabilities and the value to the business is that's missing? And let's start there. Let's build those components, start getting value out, and grow around it, right? It's very much the idea that, some working code is better than no working code, right? If we can solve part of the problem today, or part of the problem in 6 weeks, that's a lot better than waiting 6 months for the whole problem. So let's start, have something we can build around, and keep going out from that. And if you do that in the right architectural way, right, you're both validating the choices that you're making as you're going. They're able to adjust their roadmap. And when something's wrong, and it will be, right, because it simply always will be, somebody's going to pick something wrong, be it a platform, a business requirement, right, some direction that changes. You'll have enough pieces of real value to pivot around, right? And some of those core capabilities like storage that we're not going to have to rip down. And so we can begin to actually add value around it for the new value without having to spend the time constantly rebuilding the first 7 pieces every time we find there needs to be a change. Does that answer your question? I like how I said that, and I actually can't see anyone for them to respond, but I hope that answered your question. And if not, feel free to ask it again.
I think that's the amazing answer. And we have another question. How was find your passion to be an expert in this topic?
For me, I think the answer is anything that helps people find new ways to solve problems or better insights, right, into the problems they're facing is fascinating. And what's wonderful about this space is, as it's matured into an ecosystem, you might take any one piece of it and find it horribly boring or, repetitive to build, but there's so many other pieces that are going to get brought to the table, right? It's very easy to find the piece that really is helping you drive value, right? Or make changes that you feel is impactful. And it's always rewarding once you've lined that piece up. And so, it's no longer, hey, somebody sits in a room and writes 40 SSIS packages that they manage for 10 years, right? There's so many pieces to this that you still have to do all the heavy lifting, but there's a lot more places where you get to touch the interesting pieces and actually see that value with the business a lot sooner.
Wow. And we have the last question under this ELT model. How do you ensure information integrity and security, since you might be extracting sensitive and sensible information without being aware?
That is a great question. And there's a few different pieces to it, right? One, there is absolutely simply a process, procedures, and security right answer to this, where your unstructured data can't just be publicly available to everyone in your organization. But what is great about a lot of the tool sets is you're beginning to see capabilities in there that let you build these data policies and apply them in much more dynamic ways, where they can use things like AI to help you identify security numbers or credit card numbers or other pieces of PII in data and flag it, even when it's in unstructured data, right? And so there's got to be enough policy and guidance around it. You can't just assume the tools are going to fix it all for you, but you really can begin to put together operations and procedures that really begin to limit that exposure, help you know how it's used. And as we begin to look at these tools, one of the things we didn't talk about was tracking lineage, but that's a really, really key piece of not only the pipeline tools, but a lot of the governance tools that are out there now, so that you can also trace the impacts of where data is coming from, where it's going to, and how much you know about the security of its content, right? Has this been cleared? Do we know it's PII free? Is this unknown data that may be of risk? And apply different policies to it based on those classifications. So that gives us some ways to, depending on what we're doing in our industry, right? Build processes that let us manage what we know, how we want to, and what we don't know based on what our risk tolerance is, right? And based on the risk of what we're working with is. And if I'm in a higher risk or higher compliance field, that probably means that data that is not classified, right, is treated as more sensitive until it's been cleared. And that's fine. There's ways to do that in a lot of these tool sets now.
Thanks for your answer, and we have all question answer. And thanks for being here and listening to this fantastic and exciting talk with Rich. Thank you, Rich. And we want to invite to our other talk the next Wednesday, and we hope see again all. Thanks a lot, Rich.
Thanks, everybody. Thank you for your time today.